Thank you very much. It's actually quite the outcome. I expected I scare off more people with the term Fortran. All right, cool. So because the joke needs to be played a little bit further, who knows what Fortran is? Oh God, can I take a picture of that play? Oh my God. Okay, so that slide here is completely useless to all of you because everyone understands what that does, right? You know the 99 bottles of beer? I think 99 bottles of beer.net. If you don't, it's a great source for any kind of programming language. It's basically the same thing, like there's 99 bottles of beer on the wall, blah, blah, blah. And I think in every single programming language ever created, including brainfuck. Just because, right? But the interesting thing about Fortran is that it was created in 1957. Who was alive at that point? Nobody? Whew, okay. Okay, we're at least something. But you know what is more scary about that? Who can guess what the last release of Fortran was? Or when? What? 2010, close. 12, very close. Nope. 2023, very close. Like exactly, Jesus. Oh God, yes. So I was also very much blown away when I saw that. So the smiley is not just a smiley. It was like my face at the point in time. I wanted to make the joke like, you see, it hasn't developed in like, I don't know, ages, and then that. And I'm like, oh, okay. So that didn't play out as planned. All right, anyway, I'm Chris. You heard that. I'm working for simplyblock. I'm basically the developer advocacy team, the marketing team, and everything in whatever technical marketing we have. The company is fairly small, as you can figure out. I've been with a few companies in the past. One or two people might have heard about Ubisoft, probably in the sense of copy protection. I don't know. That was not me though. Just making sure. But apart from that, it was always something with data. Hazelcast was an in-memory data grid. Instana is all about observability, or was before it was acquired by IBM. Cleverbit was my own startup, and we did like animal husbandry metrics for animal barns, basically collecting like CO2, ammonia levels, correlating that with like medication levels and stuff, and try to give them like the animals a slightly better life, at least for the time being. And Timescale is a time series database on top of Postgres, which I would very much recommend anyone. Postgres is a great database. Timescale is awesome. But apart from that, I love fairy tales. Fairy tales, especially in terms of benchmarks. Who believes AMD is faster than NVIDIA? Who believes NVIDIA is faster than AMD? Who believes that Intel is just like the fastest of all of them, right? To be honest, I mean, I was quite shocked. Like, was it like 5 or 4 years ago when I saw like the first PCI Express graphic cards from Intel? I was like, what? When did that happen? What weird stuff happened during COVID? Like, were you like all forced into a single room and you couldn't get out, right? Anyway, what is iSCSI? I guess you all know Fortran, so please tell me you know iSCSI. Oh, God. Thank you. Okay. All right, so iSCSI, right? We all know the SCSI protocol. iSCSI was basically the idea of tunneling that through TCP or like other options like Fibre Channel, Infiniband, all of that kind of stuff. And it basically gives you an option to get a block device remotely attached. I think that is fairly simple. But the interesting thing is, can anyone guess when the protocol was released originally? What? 1995? That is too early. That would be even scarier. You said 2005? Well, let's say it was somewhere in the middle, pretty much, right? So since 2000, and it doesn't have developed a lot. There were some revisions, but nothing fancy happened, right? So let's say iSCSI is like a little bit older. I can say that I'm older than I look, which is, I guess, the good way of saying things, right? The other way around would be bad. But looking at that age, right? Let's quickly remember what our life looked like in 2000, especially in the technology world. When did the first iPhone came out? All right, 27. Good, good. When was the Xbox One? Or no, sorry, the OG Xbox, the first Xbox, not the Xbox One, right? Very confusing thing. Anyone? No, it must be earlier. It must be earlier than 2007. We're going backwards in time. 2001, yes. Very, very close. The PlayStation 2. Are there gamers in the room? You should, okay, so you should know that. Nah, that's a bit early. Why would we go further than 2000, right? No, it actually came out in early March 2000. But what is more scary, that is what phones looked like at the time, right? That is September, that is newer than the PlayStation 2. Just saying, right? That is what our world looked like. Who remembers having a Nokia phone? Is the battery still charged? Right? And originally, I took this talk to a Java conference. So you might not know that, but what Java version was around at the time? Any guesses what Java version we're up to now? Like, what is the latest Java release? Okay, good, good. So we were at 1.3, which came out in May 2000. That is a long, long, long time back. I think the world looked very different at the time. So why were we still using iSCSI as a protocol, right? I mean, the world didn't even know what a SSD is at the time, I guess. Maybe just barely, right? We knew what flash memory is, but NVMe wasn't a thing. And we're still using NVMe flash storage solutions over iSCSI. I don't understand why. So, right? So all of that out of the way. Yay! Why is the animation not working? I don't know. Broken slides. Oh, there you go. Oh. How did I do that? Oh, I think the animation isn't starting automatically. Ooh, okay, so we got the animation. We're good. No cat though. Sorry, left that out. So the other thing is, like, what is NVMe? I think the problem is, well, the interesting part about this question is that NVMe has a very overloaded utilization these days. So most people, when talking about NVMe, probably think about that, right? Like NVMe over TCP attached storage devices, which is not wrong, but it's also not exactly right? So that's, well, some people call it NVMe SSDs. Some people use SSD. Some people use NVMe like very broadly. But the problem is that is also NVMe. It's the port specification, right? So there's, and that is not actually like, those are different connectors. It's the, what is it, like UG2, UG3 something for the more enterprise side. And then you have like the typical M2, whatever keyed thing for this consumer market, right? Like that stuff. And I think the current version is U3, U4. I kind of lost track. There's a newer version of the storage. But the other thing that it is, it's a very readable, very lightweight, 700 pages specification. And it says base specification for a reason, because I think there's like 15 other specifications that just build on top of that, all with like 200 to 500 pages each. As I said, it's very digestible. It's super, super fun to read in your vacation. So if you ever go to Bali and you're bored, just sitting on the beach, right, being sunburned and stuff, that is a beautiful read for that. You won't understand how fast you actually go and fall asleep. But as I said, there's more specifications on top. So the base specification is basically just like the very, very basic set. It defines the command set. Then there is the express base specification, which basically is the specification like how to communicate over PCI Express. Then you have the boot specification, how to boot from NVMe. You have the management interface, and then you have the transport interface, which also is part of the PCI Express specification, but it also defines a couple of more things. It already says like RDMA and TCP. So the NVMe thing, like NVMe as a thing, is much broader than just that what we normally think about. And I think the protocol is the important part here. And most specifically, we're going to talk about NVMe over TCP or NVMe over Fabric. So for a very quick history lesson, just to see how old the people are, and I'm not as old as that one, luckily. So who remembers the small memory drive interface, I think, SMD? It's not the SMD components on today's PCBs. Okay, nobody, good. Whew, that gives me a good feeling. The Sugared interface. At least everyone into retro computing is probably aware of Sugared. If you don't know what it is, search for retro computing on YouTube. There is like 1,000,001 videos about that, because basically every early computer had that. Then RL and MFM, that is probably a couple of more people, right? So that's like the thing where people really started to look into. Then we already have the SCSI interface at 85, which is kind of scary, right? So iSCSI actually uses a protocol which is much, much, much older already. That is what everyone knows, I guess, right? The IDE interface. SATA, iHCI, I think that is obvious. SAS, the more fancy version for enterprise gear. And then finally, NVMe Express in 2011. So between this and that, there is plenty of time to make development. And I think the NVMe consortium actually did a pretty good job. So NVMe over Fabric is, again, not just a single thing. So NVMe over TCP is just one implementation. NVMe over Fabrics is basically a specification on how to tunnel NVMe command, the NVMe command set over different types of transport layers. And transport layers could be a lot of things. In this case, right now specified is Infiniband, Fibre Channel, TCP, and RDMA, or ROCI, the RDME over Converged Ethernet. That sounds awesome, right? Just call it RDMA. It's the easy way. Plus the PCI Express. That means the way it looks like, you have a client-side implementation, which for Linux is part of the NVMe kernel stack, which is really nice. So for Linux, you don't really need anything else. Then you have the different connections. You have some server-side abstraction that offers the NVMe disk. And underneath, somehow, you have the disk. That's the easy way, right? You have like one disk, which is actually made public or made available through NVMe over Fabrics, and then from the client side, you're just connecting to that. For us, most interesting is TCP/IP and RDMA, to be honest, because those two things use standard gear, right? We don't need the specific like Infiniband switches or Fibre Channel gear or anything like that. We can literally just use any kind of switch that we already have, or well, that we can buy for free, almost free. So from an NVMe over TCP perspective, what I really like about it is that, as I said, it uses commodity hardware, which makes it very, very affordable to put not only into your own data center, but also makes it available in the cloud, right? Most cloud providers, and I don't think any of the hyperscalers offers Infiniband or offers Fibre Channel connections, but they all offer TCP/IP because that's what the internet works on, right? So that is really cool. It is very low latency. We're going to see that in a bit in terms of the overhead or lower overhead compared to iSCSI and stuff. It's very high performance, and it's super easy to use. And it actually has a nice scalability and flexibility built in because it defines multipath by default. So NVMe over TCP has multipath, not in the sense of parallelism multipathing, but in the sense of failover and fault tolerance. When we want to connect to something, it's fairly simple. As I said, it's part of the Linux standard kernel NVMe stack. I'm just waiting for the one picture. There we go. Perfect. So first of all, we load the kernel driver if it's not already loaded. It's as simple as that, basically extending the NVMe stack by saying, hey, we want NVMe over TCP. And then we do something which we normally also had, very similar to iSCSI, right? So we somehow need to tell the kernel, hey, we want to connect an NVMe device which is somewhere, located somewhere, right? Normally, the NVMe stack would look or would scan the PCI Express bus. In this case, we have to actually tell it. There's two ways. That's the easy way. If you know the target IP address, just connect to it straight away. But there's also similar to iSCSI, where you basically have like a lookup server, and you can say, hey, just list me all the devices or all the virtual logical devices that are available, and return that to me. So I have some way of looking it up. But basically, what you do is NVMe to connect. I say, hey, I want to use TCP in this case. Here's my IP address. Here's my port. And I give it the device name, basically whatever my device was called on the other side. The my def should be my underscore def, just saying. And it also supports like host NQN, like the host qualifier, if you want to go a little bit deeper, right? And you see that those host qualifiers, they fairly similar look to what an iSCSI connection string would look like, right? It's the same idea. You have some namespace, you have a UID, and that's basically what your devices look like. Afterwards, if you run an ls-blk, you wouldn't notice that thing is connected remotely, which is interesting. It looks like an NVMe, it behaves like an NVMe. From that, nobody would be able to say, okay, that is remotely attached or not, which is good, because I think that makes it very compatible with basically everything we have, which is a very, very cool thing. And if at some point we think, you know, my device isn't really necessary anymore, you would basically just go ahead and say NVMe disconnect. You give it the name of the device, and you're good to go, right? Or like the device file, basically, and disconnect that. And that's it. No special magic except for AWS Linux versions, because AWS kind of messed up. At least in the AWS Linux 2, the Linux kernel does not fully support NVMe over TCP. They kind of missed some config value or whatever. Not sure how they managed that. It's a bug open for quite a while, and I guess they won't fix it. But the, what is it, like 2020 version is fully compatible and actually works pretty well. So no problem here. Just make sure that you have like the new Amazon Linux version. From a performance perspective, and that is where I think it really becomes interesting, is that if we look at random writes, and that is just so slightly small. So you have like RDMA basically on 100 gigabit, which is like the very fast one. Then you have a TCP only on 100 gigabit, which is the second one. So from the top down, right? You have RDMA on a 25 gig, which is the third one, blah, blah, blah. And then you have TCP offload, TCP only, and Fibre Channel NVMe, which I think is very confusing that Fibre Channel is actually not the fastest one. But hey, I mean, this graph is kind of weird because it mixes apples and pears, right? Like, why do you put 100 gigs and 25 and 32 on the same slide? Because it looks good, right? We all know, we only trust the diagrams we actually faked ourselves. So that is not mine, but it's very close. But I think it's interesting that the NVMe over TCP is basically in the same range as all the other ones. To give it a little bit more perspective, that's a bit easier to read. That is a direct comparison between iSCSI and NVMe over TCP, and at the end you have Fibre Channel, but forget about that. What we see is that on the same payload sizes or in the same TCP frame sizes, that NVMe actually gets a lot more done, or NVMe over TCP, which I think is very, very compelling. Why the 9000, like the jumbo frame, is actually less, I don't know. But I think the overhead just doesn't really matter at that point. So it's probably just like a mismeasurement. But the important thing is iSCSI is basically the baseline, and whatever you use, everything is faster. So my recommendation is just don't use iSCSI. Use anything else, right? For latency and IOPS, I think it's a little bit easier to look at numbers. There is iSCSI and NVMe over TCP, either each time with a fresh LUN, so basically a fresh logical volume, and one which is already filled, and you're basically just updating data. And it's kind of interesting to see that you almost double the read IOPS and the write IOPS just by switching from iSCSI to NVMe over TCP, right? Not to talk about the latency, which just comes in and halves. Can you imagine you have a task that tells you have to speed up the system, and you're basically just switching from one system to the other, and like, here's your 100% speed up, like, yay, right? That's pretty incredible. I didn't expect it to be that much faster. But there is a very extensive set of benchmarks, which I can very much recommend, organized by the guys at, or like the folks at Blockbridge. They have, I think, whatever you can think of in terms of measurement, they probably did it. It's absolutely incredible. They mostly went with the Proxmox alternative. Okay, why not? Proxmox is probably the contender to VMware after the acquisition from Broadcom. Anyone still buying new VMware stuff? Who bought it before, just to make the question fair? Okay, so at least few. All right, so Broadcom, you did a good job here, right? You basically just removed all of your customers out of the box. Cool. Very, very good. So the question is, why should I care? And I already gave like one reason, right? If you have to get a performance benchmark or a performance upscale, I think that is fair, right? It's the easiest way. And to be honest, the comparison isn't probably like super like fair, super fair in itself, right? You have a protocol which is like super old. We've seen it was like 1985, and it was designed for spitting disks. So it was never designed for flash storage in itself. And now you have, and then you have iSCSI, which came around in 2000, didn't really see a lot of stuff, which also was created for spinning disks, right? Flash storage wasn't really a thing at the time. I mean, when that came out, I think a USB stick was like 16 megabytes, right? That was already awesome. And on the other side, you have NVMe over TCP, NVMe, which is like 2011. It was designed specifically for flash storage. It supports all the necessary features for NVMe controllers and all the kind of stuff. And then you just created, on top of this already very, very new and extensive protocol, you created just a tunneling, which doesn't really do a lot. But that means it gives you performance improvements for free. You can lower the overhead. And as far as I remember, the Blockbridge measurement actually shows about 25% less overhead per packet for NVMe over TCP, which I think very sustainable or very substantial, right? It's like pack 25% more per data per packet is probably a good thing, right? But what I find most important is that you really don't have to do the translation anymore. With iSCSI, you do the translation because you send SCSI commands, and on the other side, you have to translate it into NVMe, which there is no one-on-one mapping because, as I said, SCSI was never designed for flash storage, right? So there's commands in NVMe that you can't actually tunnel through iSCSI, which makes it just so more complicated for all the storage vendors. You're going feature proving. You have the flexibility. if at some point you say, hey, I really don't want to have my NVMe over TCP anymore. I want to go the Fibre Channel route because some other team magically found some Fibre Channel hardware. Good luck, you can still do it, right? Cool thing. You just deploy it and you're good. From a use case perspective, I would basically say anything block storage should be NVMe over TCP. There is no good reason to go back to iSCSI these days. If you have local attached NVMe, cool, right? That's good. But for anything else, you should be NVMe. That means anything high performance, low latency, right? Any remote block storage. From my perspective and from what simplyblock specifically is looking into in the market is databases. We think databases are the ones that mostly benefit from that. The lower latency, the higher throughput, this is exactly what databases are looking for, right? But also virtualization, containerization. There is NVMe over TCP remote booting. I'm not 100% sure if this specification is finalized now, but it at least has some demo implementations. There is an EFI implementation for NVMe over TCP booting. Not sure if I would really recommend it these days, but give it another year or so and it will be good. But as I said, for virtualization, whatever you used before, if it was iSCSI or vSAN or whatever, NVMe over TCP is basically widely adopted these days. And that brings me to the availability. And basically everyone is either working on that or it already has it. In this case, it's Proxmox. Proxmox already has the implementation. That was asked very early this year. And because it's basically just a fancy UI thing, right? The kernel can do it. So why is it hard to implement? On the other hand, TrueNAS. I'm a big TrueNAS fan. Am I alone here? Okay. Whew. Okay. Not all alone. 4 people. TrueNAS Scale or TrueNAS Core? Okay. So all the Linux people here. I'm also running. No, it's fine. I'm also running TrueNAS Scale, but mostly because the containers. Apart from that, I found the TrueNAS core based on BSD much more stable. But hey, it is what it is. But TrueNAS is actually working on that. I think it's not ready yet, but same thing, especially on TrueNAS Scale. The Linux kernel supports it, so you can already do it, even though the UI doesn't tell you about it. Super simple. And from a vendor side, I don't know how that got in there. So we're all built on NVMe over TCP. That's our bet, and we think it's the only meaningful protocol these days for anything remote attached storage. But we're not alone, which I think is good, and that's not even all of them. Yes, there's VMware. vSAN doesn't seem to scale, I guess. But there's also NetApp, zStore, Volumes, Portworx, Micron. There is Lightbits. There is, I don't know what else. Basically, every storage vendor these days that tries to be somehow, at least on the edge of technology, has some implementation of NVMe over TCP. And just to quickly get my boss happy, let's say two slides about simplyblock. We call ourselves a cloud-native storage orchestration, which sounds interesting, right? That doesn't really say a lot of things. So let's quickly jump over that and come back to that slide later on. So from our perspective, on the top you have, as I said, we're mostly into the database space, right? So you have the database instance, Postgres, MySQL, anything that doesn't support fancy stuff like objects or things out of a box, but everyone understands how to talk to a block storage, right? And block device. You put a file system on top of that and you're good. We're mostly in the Kubernetes space. So what we normally highlight is our fancy CSI driver, which is a little bit of glue code doing all the snapshotting and stuff. Basically everything that's, you guys know the CSI interface? Okay, so for the ones that did not put their hands up, CSI stands for Container Storage Interface and was like an API designed for Kubernetes initially, at least, to plug in external storage vendors. The Kubernetes core initially had the storage vendors build in their interfaces into the core system, which everyone would agree is not very maintainable over time. So they figured out, maybe we should actually do something about that. And they developed the CSI spec, which is just a communication interface between a Kubernetes kernel or Kubernetes core and the storage provider. And it gives you all the features like, hey, I want a snapshot, I want a snapshot, I want a clone, I need a new provisioned volume, basically doing all the dynamic provisioning, all that kind of stuff for you. Anyway, underneath, we have our logical volume manager. My boss hates me for saying we're basically a fancy distributed ZFS version. He really doesn't like me to say that. But underneath, and that is where the orchestration part comes in, we can use local NVMe volumes, basically direct attached volumes, whatever. On clouds, we could use something like Amazon EBS or cloud disks or whatever. And for Amazon specifically, SSD, HDD, we actually make the difference between that. And we even can connect to S3 and do object storage underneath. And we give you all the tiering. Like from you only work on a block storage level, and define like, hey, this is what we consider cold data, like infrequently accessed. Just move that away from the expensive storage, right? But here, the cool thing is your application really doesn't need to know about that. And that's where it comes in. It's fully copy on write. We don't do anything else. That means it gives you, that's why I'm saying it's basically distributed ZFS, right? It gives you immediate snapshots. You're saying, hey, you need a snapshot. We're just taking the specific point in time in the copy and write clone. It gives you clones, forks, branches. There's like a million words of that for that. But you basically take a snapshot, create a clone, mount the clone, start up your Postgres instance, and you have a full copy of that point in time, which is really cool for storage or for database vendors or also like database users when you have like reporting, right? Who had this fun that some team actually ran like an hour-long report on the production database? Not a good thing, right? With that, not a problem. As I said, we're TCP over NVMe over TCP, optimized for database storage. One thing I find really interesting that I haven't seen anywhere else, we can actually use S3 for something else, which is disaster recovery. So we basically keep our own write-ahead lock on a block storage level write-ahead lock on S3, which means we can give you point-in-time recovery, basically rewinding your storage back to an earlier state, which is really interesting. Or because it's S3 or whatever block storage, it also object storage, it automatically is cross-zone. All right, because we're running out of time, here, if you want to remember any slide, that's the slide to remember, right? iSCSI looks like my grandpa, maybe. NVMe over TCP, that is certainly not me. I'm not that sporty. But with that, thank you very much, and questions.